Hello everyone. Today I am so intentional with my discussion. I would like to discuss and go deep with these two operators, address operator and the so-called indirection operator. Okay, so I'll be doing programming actual, and along the way I'll be discussing the behavior of uh, the these two operators, right? Address operator and what is this? Indirection operator. Okay, and for those who are not yet a subscriber of this YouTube channel of mine, this is my YouTube channel, right? Kuyaeggworld, and I would like to request to please click subscribe, and if sharing is not an issue for you, then please do some sharing of this video so that we can also help somebody or someone who are so eager to learn C programming, especially in pointers in C, because as I said, pointer in C is one of the hardest stuff in programming issue, right? So that's it, and I would like to share my online compiler. Right, we'll try to create a program, include stdio.h, right, and in main we'll try to what is this? We'll try to declare x as an integer variable, and we'll try to store 10, right, for example. And then we'll try to what is this? Declare xptr, meaning x pointer, right, as a pointer variable, and we'd like to assign the address of x, right? So here, while x has a value of 10, our xptr, a pointer variable, is now pointing at x. In fact, xptr contains what? The address of x. And the next one, we'll try to make use of the pointer to pointer variable, right? So we'll try to say xptr to ptr, right? And we'll save or store the address of the pointer variable, okay? Because under pointer to pointer variable, you can store the address of a particular pointer variable, right? So our xptr stores the address of x, and x is just an ordinary variable. Our xptr is a pointer variable, and while xptr is storing the address of x, xptr itself has also an address, right? So we'll try to make use of pointer to pointer way of storing address variables, and address of a particular variable. And in this particular line, okay, we are now actually storing whatever is the address of xptr, right? And here now, knowing that x has a value of 10, and our xptr, a pointer variable, is pointing at x, right? And at the same time, our xptr to ptr is actually pointing at our pointer variable xptr. So if we want to display, for example, 10, the value of x, number one, we can do it by way of, what is this, value of x, alright? And %d, I will try to use \n to move the cursor to the next line, and we'll use the value of x, right? And here, return 0. Okay, so when we when we run this program, right? When you run this program, of course we can see the value of x, which is 10, right? And in this particular declarations, we can actually print the value of 10 in 3 ways, right? And that is the first way. The second way is we'll try to use the so-called dereferencing. Okay? Now, dereferencing in C programming is this. Actually, I had discussed this in my previous 2 videos, but I would like to go deep today on this particular video because somebody emailed me and requested me to have this kind of video. So this is for you, Mr. X. Okay. Now here, if I want to use this pointer variable xptr and I'd love to display the value of x, I can do that by way of using dereferencing. And what is that dereferencing? Value of x, right? And I'll try to use the unsigned, right? Because I'm dealing with address now. Okay, I'm dealing with address now. Unsigned integer means what? No negative. It must always be positive. So here in this particular expression, the referencing is you are going to use asterisk operator or indirection operator. Okay. So when I say xptr, I am now trying to access or extract the value of x, which is 10. Now, how could I access or extract? Take note that in this particular line, my pointer variable xptr is actually pointing at x because it has a value of the address of x. And to extract the value of x, which is actually 10, I can do the referencing. And by way of using indirection operator. So if I'm going to execute that program, I am again, right? I am able to display 10, right? That's the referencing. Now another way is this. I can say printf, right? And then value of x. Again, I'll be using unsigned because I'm dealing with addresses now. And I can use my pointer to pointer variable, right? xptr. Actually, I had discussed this in my pointer arithmetic, right? Now, take note that while my xptr, my pointer variable is pointing at x, my pointer to pointer variable is actually pointing at xptr, right? And since this pointer to pointer variable of mine, which is xptr to ptr, is pointing at xptr, then I can extract the value of x, right? So to extract the value of x, I can use the referencing, and I will be using this to what? Indirection operator, right? This is now applying the concept of pointer arithmetic. So what is this pointer arithmetic? The evaluation will start from right to left. That's what I did discuss in my previous video. So in this particular expression, you'll try to extract this one. Alright? Asterisk xptr to xptr. Alright? And then after extracting this one, actually when you extracted this one, what you can get, alright, is the address of our pointer variable xptr. Alright? And when you have the address of xptr, using another indirection operator again allows you to extract the value of x. Why? Because xptr, right, which is actually the result of the first indirection operator, is pointing at x. So that is why when we execute the program, right, we still display the value of x, which is 10. Right? So there are three ways to display the value of x. So that's it. And another one, if we want to display, what is this? If we want to display the address of x, we can still do that. How? Very simple. Address of x, right? And then I'll be using unsigned again. I'd love to use double backslash in here to have an extra space or extra line, and then to display the address of x, I can say, right, I can use address operator, right? This address operator will extract the address of x. So when we execute the program, all right, what is this? I have this. I think I can use, I don't know, D. Let's see. Right. So to be safe, I'll be using this one, and okay. Now never mind the error. Actually, I can use P here, no problem. But in this particular video, I'll just be consistent by using %u. It's a data placeholder for an unsigned integer or value. Okay. So now here, this is now what? This is now the address of x, and I was able to display that because I did use the extractor address operator, right? Now, how about the other ways? Same with the value of x. We did display it in 3 ways. So if we want to display the address of x, there is another way. Okay, address of x. Look at this, \n. Now take note that when we say asterisk xptr, right, we declared it as a pointer variable, and we stored the address of x. So we can therefore display the value of xptr, right? So when we are going to execute the program, then we have this address. Now, do not be confused. Every time we run the program, the address changes, right? It will change. And in this particular execution, the address of x is this one. We got this through, right, address operator, and we got another address through displaying, right, the value of xptr, because in our declaration we are actually storing the address of x to xptr, our pointer variable. And how's the last way? We can again print the address of x by way of dereferencing. We'll try to use indirection operator asterisk and we'll try to use our pointer to pointer variable xptr to ptr, right? A while ago I did use, right, the double indirection operator with a pointer to pointer variable xptr to xptr, and I was able to display the value of x, which is 10. Why? Because our pointer to pointer variable is pointing at xptr, which is our pointer variable, and then our xptr is actually pointing at x, and to extract the value of x we'll use indirection operator x. Now here, a while ago also I made mention about pointer arithmetic, and that in pointer arithmetic the evaluation will start from right to left, and I did mention also that the evaluation of this will start from here, right, in direction operator xptr to xptr, and it gives us the address of, right, the address of right, yeah, x. Okay, so when we have this double indirection operator, it allows us to extract the value of x. Now in this particular example, in this particular line, we are trying to extract, right, the content of xptr. Alright, the content of xptr, which is actually the address of x. So we'll try running the program and look at that. Okay, so we have this, right, displaying the address of x by using address operator, and the second one is we did display the address of x by using whatever is the content of our pointer variable xptr. And then the third one is we are able to display the address of x by way of making use of the pointer to pointer variable, and we tend to apply the dereferencing by way of using indirection operator, single indirection operator. Okay, so that's it. Like I said, pointer topic is a little bit hard, and for my viewers, I would like to suggest, if you cannot digest this discussion in one way, please rewatch the video and analyze, explore. You know, you can Google pointer topic and you can see a lot of materials there. Just try to do some filtering and look at those approaches which are actually easy for you to understand and digest. Okay. Now, I did mention also that while a pointer variable is storing address from an ordinary variable, pointer variable itself has an address. And even the pointer to pointer variable contains an address, right? So if, for example, we'll display the address of xptr, which is our pointer variable, and is pointing to x, how is that so? We'll be using printf again, right? And we'll try to display the address of xptr, our pointer variable, and we'll still use what? %u. How is that so? We can say, right, xptr. We'll use, diba? We'll use address operator, ampersand, right? And when we execute this program, then we have this, right? This is actually the address of xptr, right? And how about if we want to display the address of xptr in another way? We'll try. Let's see if it works, right? Address of xptr in some other ways. We'll try to look at it. Okay. How is that so? Here we can display the value of, right, pointer to pointer variable, because our pointer to pointer variable contains the address of xptr. Alright, so we can use what? Xptr to ptr. This is our pointer to pointer variable. So when we execute the program, right, we have this address of xptr, and we got this from our pointer to pointer variable values, right? And I think we can still extract. I don't know. I think that's it. This is it. There's no other way that we can extract the address of xptr. Right. There's no other way, I think. I'll try to imagine. I think this is it. There's only two ways to display the address of xptr, our pointer variable. And the last one that I'm going to share, if we want to display the address of our pointer to pointer variable, alright, how is that so? Okay, how is that so? We will make use of address operator and xptr to ptr. Okay, and we'll double the backslash n, And when we run the program, alright, we are now having this address, and this is the address of our pointer to pointer variable because of this address operator. Okay, so now look at this. We'll try to think of the pointer arithmetic, the topic on my previous video, wherein we try to add integer to an address, right? So for example, if this is an address of x, and if we tend to add 1 plus 1, 1 there means 1 times 4, because the memory allocation of, right, a pointer is 4 bytes. You get it? So here, look at this. This is the address of x, right? And xptr is another address. So meaning our C compiler will then create another address, and the next address out from the address of x must be the address of xptr, or pointer variable. So the address of x plus 1 must be the address of our xptr, right? So our x address is 844 plus 1 times 4, that's 48. Get it? Okay, you get it? So that's pointer arithmetic. And from here, since we are using pointer to pointer, alright, so the address of xptr, which is 848, right, plus 2, it's a pointer to pointer, plus 2 times 4, and that makes it 856. So if we look at it, there is this pointer arithmetic happening inside the central processing unit. Okay, so every time we declare a variable, there is this computation inside for the addresses, right? So at least we have an idea here, and I'd love to go back in here. Okay, we are assigning 10 to x, and in this particular line we are assigning the address of x to xptr. And another explanation of this is our xptr is now pointing at x, and at any time of our program we can extract the value of x through xptr because our xptr has a connection to x. And on the third declaration, we are trying to declare a pointer to pointer variable, which is xptr to ptr, and what we are storing is actually the address of xptr, which is a pointer variable, right? So we have this pointer variable and we have this pointer to pointer variable. The purpose of this pointer variable is to store address from an ordinary variable, and our pointer to pointer variable will store an address from our pointer variable. And from our pointer to pointer variable, we can extract the value of x, and we can even extract the address of x because our pointer to pointer variable is pointing at xptr and our xptr is pointing at x, right? So that's it. And I hope I was able to share my knowledge in pointer in C, and I hope I was able to discuss the behavior of the address operator and the so-called dereferencing, right, by way of using indirection operator, which is being represented by an asterisk. Thank you so much for watching this video. God bless you. If you have some questions, please feel free to do some comments, or you can email me, or you can chat me anytime, and I will create a video for you. That's it. God bless you. Goodbye for now. God is good.